Good morning. As promised, I wanted to go ahead and get the slide presentation to you all as it relates to the bringing together the numbers, numerals, digits, as well as different number systems, and trying to connect it to how we currently use our decimal system. So throughout this presentation, we're going to look at how to convert numbers in different bases. We're going to look at how to name various place values based on the number systems. So starting out, we have here a number. And of course, it's a number because it's a measurement of, or a quantity that actually we can see or connect to a different idea. So in this case, I have a total of 16, 17, 22 here. So this number here, this idea is 22 items. So this is your number. And my numeral name, again, will be 22. Now the numeral symbol is what's going to vary depending on how I group it or depending on the number system or rule that I use. So the numeral symbol is dependent on the number system. So if I was to take this number or the numeral 22 that represents the number and convert it in our base 10 system, in order to know how it actually will fit in, I need to name the place values. So now I always start off with the unit. I know that I can have 1 group, 2 groups, 0 groups, 3 groups, 4 groups, 5 groups, 6 groups, 7 groups, 8 groups, or 9 groups of 1. However, if I was to add another unit to that, I would have to write that as a 10. So, and of course we know that we can have up to from 0 to 9 groups of 10. And then once I get to the 10th group of 10, that would be 10 tens or hundreds. Same thing with the hundreds. I can have anywhere from 0 groups of 100 through 9 groups of 100. But as soon as I get 10 groups of 100, that's the same as saying thousands. So once you've actually named your place values, you can proceed with rewriting or converting your number into a numeral symbol depending on the base system that you're working in. And in our case, we're actually working in 10 this time. So notice as I actually move the items over, I want you to see how they fit into the place value system. So 1, and you notice that the one that was here, I moved it here. 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 groups of 1. However, again, when I add another group of 1, that'll be 10. So that's where my one group of 10 comes from. And then I'm going to add another one, 11, 12, 13, 14, 15, 16, 17, 18, 19. And again, I cannot have more than 9 groups of 1. So that means if I were to add another one, that would be a 10. So then I have 20, 21, and 22. So looking at my place value system, I have 2 groups of 10 and 2 groups of 1. So the numeral in base 10 that represents the numeral 22 would be just that. Let's take a look at the number that's named by the numeral 22 in a different number system to see what different numeral symbol would represent that quantity. So I want to take a look in base 2. And just like in the previous base system, you want to first name your place values. So in base 2, that means I can only have 0 or 1 groups of any amount. So in this case, in my ones place, if I had 1 group, I can't have 2. I can have either 0 or 1 group. Once I have 2 groups, I need to move over to the next place value. So then that means I would have 2s. I can have 0 or 1 group of 2s, and then as soon as I get 2 groups of 2, I need to move over to the next place value, which will be my 4s. I can only have 0 or 1 group of 4, so that means that 2 groups of 4 will be my next place value, which is 8s. Same with 8s. I can have 0 or 1 group of 8, but I can't have 2 groups of 8 because there's no such thing as that digit in base 2. So as soon as I have that, I move over to the next place value, which will be 16. So once again, I've named my place value system. And of course, it would continue on depending on how big of the number you're trying to represent numerically. And in this case, for base 2, my place values are units, 2s, 4s, 8s, and 16s. Notice in base 2, every time I get 2 groups of some amount, it moves up a place value. So 2 groups of 1 would be 2s, 2 groups of 2s would be 4s, 2 groups of 4s would be 8s, and so forth. So if I was taking my number that's named by the numeral 22 and trying to rewrite it symbolically in base 2, I would start off such as this. 1. And notice I had 1. I can't have 2 groups of 1. As soon as I have 2 groups, I need to move over to 2. Then I have 3. And then if I was to add 1 more, I would have 4, which would be 2 groups of 2, which I can't have, which is why I'll have 1 group of 4, 5. I can't have 2 units, but I can have 6, 7. If I add another 1 unit, that would give me 2s, which would be 1 group of 2, which would give me a total of 2 groups of 2, which would give me 1 group of 4, which would give me 2 groups of 4, if that makes sense. So right now I have 4 plus 2 plus 1, which is my 7. So 8 would be represented as 1 group of 8. And then I have 9. And then this is how I would represent 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Notice I never had more than 1 group of the amount. So in looking at the number, right now I have 20. So then I have 21. And then I can't put that 22nd object in the unit space because then I'll have 2 groups and that's impossible. So then I'll move it over to 2. So now I have 1 group of 16, 1 group of 4, 1 group of 2, which is 16, plus 4, which is 20, plus 2, which is 22. So my numeral will be 1 group of 16, 0 groups of 8, 1 group of 4, 1 group of 2, 0 groups of 1, and base 2. So look at the table here, and you'll see how my numeral for the quantity 22 is this in base 2, and it's this in base 10. So again, it's still representing the same number, the same numeral name, but it's symbolically represented different as it relates to the specific place value system that we're working in. And you all kind of went over that as well when you looked at the different number systems, because you still were representing the same numeral quantities, however, they just were symbolically represented differently. And that's the whole idea here. Okay, let's take a look now at the same number that's named by the numeral 22 and see how it's symbolically written in base 3. So again, just as in the other examples, we're going to need to name our place values. So in this case, in base 3, the place value is units. And then in base 3, that means every time I get 3 groups of some amount, it moves me up to a larger place value. So if that's the case, that means that each place value can hold from 0 through 1 and 2 groups. So in this case, if I had 0 groups of units, it would be 0, 1 group, 2 groups. As soon as I get 3 groups, it moves me up. So that means my next place value name would be 3s. So I can have from 0 groups of 3, 1 group of 3, 2 groups of 3. As soon as I get 3 groups of 3, I need to move up to the larger place value, which will be my 9s. 1 group, 2 groups. Again, 3 groups of 9 will be 27. 1 group or 0 group. Remember, 0, you can always have 0 groups of these amounts as well. 1 group, 2 groups. And then as soon as I get 3 groups of 27, it moves up to the larger place value, which would be 81. Okay, now, or once I get my place value names, then I can figure out, the place value names tells you how the number is grouped. Because remember, the digits represents the different groupings for the place value names. So now I can take the number that's represented by the numeral name 22 and regroup it and represent it symbolically. So I can start with 1, 2. Now, as soon as I get 3, I can no longer represent it as 3 ones. It has to be represented as 1 group of 3. So I have 3 there. Now I can have 4, 5. And again, I cannot have 3 groups of units. However, instead of writing it as 3 groups of units, I can rewrite it as another group of 3, which would be 6, 7, 8. Again, when I put that 9th one there, it's going to make 3 groups of 1, which is the same as another group of 3, which would be a total of 3 groups of 3, which I can't do. So I'll have to rewrite 9 as 1 group of 9. 10, 11, 12, 13, 14, 15, 16, 17, and again that 18th one, I would generally rewrite the 3 units as one group of 3, but then that would cause me to have 3 groups of 3, which I can't have, so then I would have to rewrite it as a group of 9 for a total of 18, or 2 groups of 9. So that's 18, 19, 20, 21, and 22. So now I have a total of 2 groups of 9, 1 group of 3, 1 group of 1. Remember, the digits or the symbols represents the number of groups of whatever that place value name is. So there's my numeral for the number or the quantity 22 in base 3. Okay, since we know how important the place value name is, I want us to practice rewriting the names of place values for base 4, 5, and so forth. So the first one, for base 4, I want you to pause the PowerPoint, give yourself some time to think through what would be the place value names for base 4. Hopefully you've actually paused the presentation and you found that for base 4 in the units, if it's base 4, that means you can have 4 groups of some amount for each place value, which means that in units I can have up to 3 groups. So 0 groups of units, 1, 2, or 3. When I have 4 groups of units, that would be my next place value, which is 4s. I can have 0 groups of 4, 1 group of 4, 2 groups of 4, 3, and so forth. So my next place value would be 4 groups of 4. Again, I can have 0 groups of 16, 1 group, 2 groups, 3 groups. 4 groups of 16 would be my next place value name, which would be groups of 64. And the same thing, I can have 0, 1 group, 2 groups, 3 groups. And then once I have 4 groups of 64, that will be my next place value system, which I believe is 250 groups of 256, I believe. Okay, same thing I want you to do for base 6. And if you've done it correctly, your place value name should be units, 6s, 36s, in groups of 216s. So in looking at the patterns, in base 2, I had 1s, groups of 2s, groups of 4s, groups of 8s, groups of 16s. I want you to pay attention to how it's growing. Each place value for base 2 grows by groups of 2s. So it exponentially grows. So I have 2 groups of 1, I have 2 groups of 2, I have 2 groups of 2 groups of 2, I have 2 groups of 2 groups of 2 groups of 2. So it's always 2 groups of the previous place value. So again, it's exponentially growing. So here's the exponential representation. Same thing for base 3, 4, 5, 6, 7, 8, 9. And of course for base 10, that's exactly how our base system grows. We know that the place value name grows exponentially by 10s. So I have 0 groups of 10, which I don't have any groups of 10 because I only can have from 0, 1, 2 up to 9. The next place value will be groups of 10. The next place value will be hundreds because it's groups of 10, and so forth, thousands, 10,000s, and the system extends itself. Now, in class, you all received a practice sheet to use in converting between different bases. And I want to do an example for you all in that you can refer to and reference in completing the actual activity. And with this particular activity, I want you all to first, anytime you are provided with a numeral, in this case, I'm presented with a numeral, a symbolic numeral in base 3 of 1202. So first of all, I need to know what numeral name that represents. So I have 1 group of 27, because again, this is in base 3, so that means my place value names will be units, 3s, 9s, 27s, 81, and so forth. So I have one group of 27, two groups of 9, 0 groups of 3, two groups of 1. So the importance of expanded notation is expanded notation helps us to see how digits and specific place values expand out to the actual numeral name for that value. So this is the representation 127, one group of 27, two groups of 9, two groups of 2. And expanded out, you would have this expression, which is 47. One group of 27 plus two groups of 9 plus 0 groups of 3 plus two groups of 1 gives a numeral name of 47 for the numeral 1202 in base 3. Now, what if I wanted to rewrite this numeral in base 4? Again, the numeral name does not change. The number doesn't change. The number is always the idea of 47 objects. We're just trying to figure out how to rewrite them or regroup them depending on the base. So if I was to take the numeral name 47 and rewrite it symbolically in base 4, I would start off with finding out what are the different place values for base 4. So in base 4, that means anytime I have 4 groups of some amount, it moves up to the larger place value. So if I have, in the ones place, I can have from 0, 1, 2, 3 groups. So then I have 4 groups of 4. That means my next place value will be 4s. I can have from 0, 1, 2, 3 groups. So as soon as I have 4 groups of 4, the next place value will be 16. The same goes on. So I can have 0 groups, 1 group, 2 groups, 3 groups. As soon as I have 4 groups of 16, I'll have to move forward to the 64 place value and so forth. So in this case, I'm taking the numeral name 47 and I want to rewrite it in base 4. So that means that the number 47, okay, so the number is the idea of the objects. The numeral name is 47, so this is what the number looks like. I want to take that number and regroup it based on base 4 or rewrite it symbolically in base 4. So looking at my place values, I can have groups of 1s, groups of 4s, groups of 16s, groups of 64. Well, I know I would not have any groups of 64 because that's larger than the number. The number is 47. So with 47, the next place value down will be 16s. So I'm going to look to see, how many groups of 16 can I measure out of the 47? So there's one group of 16. There's another group of 16. I can only do 2 groups of 16 because clearly I don't have enough to make a third group of 16. So now I go to the next place value, which are my 4s, and I'm going to look for groups of 4. So I can measure out 1 group of 4, 2 groups of 4, 3 groups of 4. I cannot measure out more than 3 groups of 4. I don't have enough. So then I go down to the next place value, which is my units, and clearly I have 3 groups of 1. So if I was to write this numeral in my place value chart, it would be 2 groups of 16 plus 3 groups of 4 plus 3 groups of 1, which is the symbolic numeral of 2 groups of 16, 3 groups of 4, 3 groups of 1, or 2, 3, 3 in base 4. What I would like for you to do now is, with that information, if you need to replay the PowerPoint or to go back, please feel free. But with that information, I want you to practice by completing the numbers and numerals activity that was provided for you in class. If you have any questions, please feel free to email me, call, or text. I will be uploading your presentation for tomorrow's class very shortly. Have a great evening.